So here's a random question with a surprisingly technical answer. What's the best way to destroy a PNG file? Now, I'm not talking about deleting PNG files, I simply mean the best way to corrupt a PNG file and end up with a cool looking result. One way would be to try and edit the file in a hex editor, but if you try this, you'll notice that most of the time the PNG simply turns into a blank image. To understand what is going on here, and to figure out how to make something interesting, we need to understand the PNG file format. PNG files start with an 8-byte signature followed by a series of chunks that contain image data and metadata. Each chunk follows the same structure. The first 4 bytes store the data length of the chunk, the next 4 bytes hold an ASCII string indicating the chunk type, then comes the chunk's data itself, and finally, there's a 4-byte CRC checksum that can be used to detect if the chunk's type or data have been altered or corrupted. The actual image data for the PNG is contained in the IDAT chunks. So with the basics out of the way, you might assume it's the CRC value that's preventing PNGs from glitching. After all, if you edit the image data, the CRC isn't going to be valid anymore. But it's actually a multi-layered problem. In addition to the CRC value, the underlying compressed data stream is just really fragile. If you mess around with it, the image decoder often doesn't know how to proceed, so it exits. Sometimes you'll get lucky and something weird will appear, but most of the time you wind up with a blank or partially decoded image. So, how do we get around this? Well, I went poking around and found a really neat article from a little over a decade ago by a developer and artist known as UCNV. In this article, he suggests that image data should be glitched in the first stage of its compression process. You see, prior to image data being compressed with the deflate algorithm, each scan line in an image is first transformed into a more compressible state by one of 5 filters: none, sub, up, average, or path. With the exception of none, these filters attempt to make the data less random and more repetitive, which helps the deflate algorithm work more efficiently. For example, the subfilter works by replacing each byte of pixel data with the difference between its actual value and the corresponding byte of the pixel to its left. In the case of horizontal gradients, you're left with a lot of small, repeating values, which often compress better than the original data. Each filter has its own mechanism for transforming the data, and all of them are entirely lossless and easy to reverse to reconstruct the original data. So instead of corrupting the fully compressed data, we decompress it into its filtered state, mess with that, recompress it, put it back into the PNG file, and then fix the CRC values. This may seem a little convoluted, but it leads to some pretty cool results. For example, normally an image is encoded using various filters, with each scan line using the filter that most efficiently optimizes its data for compression. But if we go in and switch the filter byte of every scan line to, say, the path filter, now we have a mismatch of filter type and filtered data, and we get some pretty wild looking images. Even if there are lines in the image that already use the path filter, most filters factor in neighboring pixels from the line above, so errors often cascade down through the image. This kind of incorrect filter glitch is neat because each of the 5 filters has its own type of artifacts which it leaves on the image. Another thing we can do is re-encode every line to use a specific filter, and then glitch the encoded row data. This lets us see how errors percolate through the image for a given filter type. For example, for the subfilter you get colorful scan lines which move to the right, which makes sense because the subfilter only looks at a pixel's left neighbor, so once an error happens, all the pixels to the right get screwed up. For the up filter you see something similar except the glitches move down from where the error occurred. The average filter produces a neat effect because each error is a little dot with what looks like colorful gas leaking out. And the path filter is, well, very chaotic looking. For completeness, I should also mention the none filter. This one is just a bunch of dots because the none filter doesn't transform the pixel data using its neighbors, so errors don't really do anything interesting. One thing I realized while messing around with these was that you're not actually limited to just the 5 filters that the PNG spec specifies. You can actually see what errors look like with any type of filter you can think of. All you have to do is transform the image rows using your custom filter, glitch this data, then transform it back into the regular scanline data, then re-encode it using one of the standard 5 PNG filters, compress it, and put it back into the PNG. For example, here's what glitched image data looks like using a custom XOR filter I made. It creates this cool running paint look. And here's another result I made with a custom filter that uses some extended neighbors. It creates this glitchy blown out image look. And to complement the up and sub filter, here's a glitched image using a diagonal filter. I was curious if there were any filters that the PNG spec authors had considered but left out, and I found in an older draft of the PNG spec that they had planned for a cross filter. I implemented that and glitched its data and got this. It's kind of similar to the path filter's results, though it's significantly less chaotic. I kind of like it though. There's probably endless filters one can make messing around with this stuff, and I wouldn't be surprised if there were other filters the PNG team had considered but didn't implement. Another neat thing you can do, and I've shown a few of these during the video, is glitch animated PNG files. And the same concept of glitching filters works for them too. Most modern browsers support animated PNGs, but coming across one in the wild is still kinda rare. So, to answer the original question, the best way to destroy a PNG file is to mess with its data while it's in its filtered state. If you want to see what happens to your own images, I've added some filter glitching options to my image glitching app. And if you're a developer and want to try this out yourself, I'll put a link in the description to an open source library that UCMV created for PNG file glitching, along with his original article. Anyway, that's all I have for you today. Thank you for watching.